Welcome to Relaxing Facts Studio, a place where curiosity meets calm exploration. In today's video, we invite you to slow down, take a deep breath, and gently expand your perspective. The universe we live in is far larger, deeper, and more astonishing than our everyday experience suggests. Beyond the stars we recognize and the galaxies we imagine, there is a vast cosmic scale that challenges human intuition in the most fascinating way. This is not a story of speculation or drama, but a quiet, guided journey through what modern science has discovered so far. Settle in, relax, and let's explore just how big the universe truly is. When people ask, "How big is the universe?" they are asking one of the most natural and enduring questions in human history. It sounds simple, yet the answer stretches far beyond everyday understanding. The universe is not just large in the way an ocean or a continent is large. It is vast on a scale that challenges how we think about distance, time, and even imagination itself. To begin, it helps to recognize that size in the universe is not measured in familiar units like miles or kilometers alone. Astronomers often use light years, a measure of how far light travels in 1 year. Even with this unit, the numbers quickly become enormous. Our own galaxy, the Milky Way, spans about 100,000 light-years across, and it is only one galaxy among many. When scientists talk about the size of the universe, they are usually referring to the observable universe. This is the portion of the universe we can see from Earth, limited by the age of the universe and the speed of light. Light from regions beyond this boundary has not had enough time to reach us yet. As a result, the observable universe forms a vast cosmic horizon around us. What makes this question even more intriguing is that the observable universe may not represent the universe as a whole. There could be regions far beyond what we can ever detect, extending in ways that current science can only describe cautiously. In this sense, asking how big the universe is leads us to a thoughtful realization. The universe is not only immense in size, but also in mystery, inviting calm reflection rather than final answers. The observable universe is the part of the cosmos that we can study and measure using light, telescopes, and scientific instruments. It does not represent the entire universe, but rather the portion that has become visible to us since the universe began. Understanding this concept helps explain why the universe can feel both immense and limited at the same time. Light travels at a finite speed, and because the universe has a known age, there is a maximum distance from which light has had enough time to reach Earth. This boundary defines the observable universe. Objects beyond it may exist, but their light has not yet arrived, making them inaccessible to observation with current technology. The observable universe is often described as a sphere centered on the observer. From Earth, it extends roughly 46 billion light-years in every direction. This number may seem surprising, since the universe itself is about 13.8 billion years old. The reason lies in cosmic expansion. While light has been traveling toward us, space itself has been stretching, increasing the distances between galaxies over time. It is important to note that the observable universe does not have an edge or a wall. Instead, it marks the limit of what we can currently see, not the limit of what exists.
As time passes and technology improves, this observable region can change, allowing us to detect objects that were once beyond reach. By focusing on the observable universe, scientists can build reliable models of cosmic history and structure without making assumptions beyond the evidence. This approach keeps modern cosmology grounded, careful, and open-ended. In this way, the observable universe serves as both a window into the past and a reminder of how much remains unknown.
When we look into space, we are also looking back in time. The question of how far we can actually see is closely connected to how light travels through the universe. Light moves at a constant speed, and because it takes time to travel, distant objects appear to us as they were long ago, not as they are today. The farthest we can see is determined by the age of the universe and the expansion of space. Since the universe is about 13.8 billion years old, it might seem logical to assume we can see objects up to 13.8 billion light-years away. However, the reality is more complex. As light has been traveling toward us, space itself has been expanding, increasing the distance between galaxies over time. Because of this expansion, the most distant light we can observe today comes from regions that are now much farther away than when the light was first emitted. This creates a visible boundary known as the cosmic horizon. Beyond this horizon, light has not yet had enough time to reach Earth, making those regions invisible to us for now. The earliest light we can detect is often called the cosmic background radiation. It does not come from stars or galaxies, but from a time when the universe first became transparent to light. This faint signal allows scientists to study the universe in its earliest observable stage. However, our view is limited, but it is still remarkably deep. Modern telescopes allow us to observe galaxies formed billions of years ago, offering a detailed glimpse into cosmic history. In this sense, the distance we can see in space is not just a measure of size, but a quiet record of time, stretching calmly across the universe. Galaxies are vast systems of stars, gas, dust, and dark matter, all held together by gravity. For a long time, humanity believed that our own galaxy contained most of what existed in the universe. Modern astronomy has revealed a far more expansive picture, one in which galaxies are not rare exceptions, but common features spread across the cosmos. With the help of advanced telescopes, scientists have learned that galaxies come in many shapes and sizes. Some are graceful spirals, others are smooth and rounded, and many appear irregular, shaped by long histories of interaction and change. Each galaxy can contain millions or even hundreds of billions of stars, along with planets and other cosmic material. What truly stretches the imagination is the sheer number of galaxies. Observations suggest that there are hundreds of billions of galaxies within the observable universe alone. Many of them are so distant that their light is faint and difficult to detect, meaning the true number may be even higher. As technology improves, astronomers continue to discover galaxies that were previously unseen. These galaxies are not evenly spaced. They form vast patterns, gathering into groups and clusters, separated by immense regions of mostly empty space. This structure gives the universe a rich, layered complexity that extends far beyond what the human eye can perceive. Despite their incredible scale, galaxies follow consistent physical laws. By studying them, scientists gain insight into how the universe formed and evolved over time.
In this way, galaxies remind us that the universe is not only larger than we imagine, but also more organized, revealing quiet order within its immense size.
From a human perspective, the Milky Way feels unimaginably large. It contains hundreds of billions of stars, along with planets, nebulae, and vast clouds of gas and dust. For many years, it was natural to assume that our galaxy represented a major portion of the universe. Modern observations, however, reveal a very different reality. When compared to the full scale of the observable universe, the Milky Way is only a small component of a much larger cosmic landscape. Our galaxy is part of a modest group known as the local group, which includes a few dozen nearby galaxies bound together by gravity. Even this group is only a tiny feature within a much larger structure called a galaxy cluster. Beyond clusters lie immense superclusters containing thousands of galaxies stretched across millions of light years. These structures form part of an even greater pattern that spans the observable universe. Seen from this perspective, the Milky Way is not central or unique in size, but one example among countless others. This realization does not reduce the importance of our galaxy. Instead, it places it within a broader and more accurate context. The same physical laws that shape distant galaxies also govern the stars and planets close to home. The processes that formed the Milky Way are shared across the universe, connecting our local environment to the farthest reaches of space. Understanding how small our galaxy is compared to what exists beyond it encourages a calm and grounded sense of scale. It highlights the vastness of the universe while reminding us that even a tiny part can hold remarkable complexity and beauty.
Galaxies are not scattered randomly throughout the universe. Instead, they are drawn together by gravity, forming larger structures known as galaxy clusters. A galaxy cluster is a collection of hundreds or even thousands of galaxies bound together, along with vast amounts of hot gas and unseen matter. These clusters represent some of the largest gravitationally connected systems in the universe. Within a cluster, galaxies move slowly around a shared center of mass. Over long periods of time, they can interact, gently influencing each other's shapes and motions. These interactions help astronomers understand how galaxies evolve and how gravity shapes large-scale cosmic environments. Clusters themselves are not isolated. They are often grouped into even larger formations called superclusters. A supercluster can span hundreds of millions of light years and contain many individual galaxy clusters. Unlike clusters, superclusters are loosely bound and form part of an even broader cosmic arrangement. These immense structures trace a vast pattern across the universe, outlining long filaments of matter separated by enormous regions of relatively empty space. This arrangement reveals that the universe has an underlying structure on the largest scales, rather than being uniform in all directions. Studying galaxy clusters and superclusters allows scientists to explore how matter is distributed across the universe. These structures act as cosmic signposts, helping researchers map the universe and test models of its growth over time. While their scale is difficult to fully imagine, clusters and superclusters quietly demonstrate how small individual galaxies are when placed within the universe's grand design.
Beyond individual galaxies and clusters lies a level of cosmic organization that is truly extraordinary. The largest structures in the universe are vast networks of matter, stretching across hundreds of millions of light years. These structures reveal a hidden order, showing that the universe is not random, but shaped by gravity and the expansion of space over billions of years. Among the most impressive formations are cosmic filaments. These are long, thread-like structures composed of galaxies, gas, and dark matter, forming a web that connects galaxy clusters across immense distances. Between these filaments lie enormous voids, regions where very few galaxies exist. Together, filaments and voids create the cosmic web, a vast lattice that outlines the large-scale structure of the universe. Superclusters are another example of these immense structures. They are loose groupings of galaxy clusters, sometimes extending over hundreds of millions of light years. Within the observable universe, some superclusters are so large that they contain tens of thousands of galaxies, yet they remain only a fraction of the universe's total expanse. Perhaps the most staggering structures are known as the Great Walls. These are enormous sheets of galaxies that stretch across vast cosmic distances, forming boundaries between different regions of the cosmic web. The Sloan Great Wall, for example, is one of the largest known formations, measuring more than 1.3 billion light-years across. These massive structures highlight the quiet yet extraordinary scale of the universe. They remind us that galaxies, clusters, and even superclusters are part of a much larger, interconnected network. Observing the largest structures in the universe helps scientists understand how matter organizes itself and evolves, offering a calm, awe-inspiring perspective on the vast cosmos.
The universe, at its largest scale, is not a random scattering of galaxies. Instead, it forms a vast and intricate pattern known as the cosmic web. This hidden structure is composed of filaments, sheets, and nodes made of galaxies, gas, and dark matter, connecting the universe like a delicate but immense network. It is one of the most striking examples of order on a cosmic scale. Cosmic filaments are the threads of this web, stretching across hundreds of millions of light years. They link galaxy clusters and superclusters, forming long, thin strands that guide the growth of matter over time. Between these filaments lie enormous voids, regions almost empty of galaxies, which create contrast and define the shape of the web. These voids are not entirely empty, but their sparse matter makes the surrounding filaments even more prominent. The nodes of the cosmic web are locations where filaments intersect. These dense areas often host massive galaxy clusters and superclusters, forming the universe's most concentrated regions of matter. Observing these nodes helps scientists understand how galaxies form and evolve under the influence of gravity. The cosmic web was first revealed through detailed astronomical surveys and computer simulations, showing that the universe has a hidden architecture that shapes the distribution of galaxies. This structure is influenced by the mysterious dark matter and dark energy, which govern the universe's expansion and evolution. Understanding the cosmic web allows scientists to see the universe as a connected system,
rather than isolated points of light. It highlights how everything, from individual stars to massive clusters, is part of a grand, interconnected network. Exploring this hidden structure provides a calm and awe-inspiring perspective on the universe, revealing the quiet elegance of its enormous, unseen design.
The universe is not static. Since its beginning nearly 13.8 billion years ago, it has been expanding, with galaxies moving away from each other over vast distances. This expansion is not like an explosion from a single point. Instead, it is the stretching of space itself. As a result, the distance between galaxies increases over time, even if the galaxies themselves remain largely unchanged. This process can be observed through the light coming from distant galaxies. Light from faraway galaxies is shifted toward the red end of the spectrum, a phenomenon known as redshift. The greater the redshift, the faster a galaxy appears to be moving away. This observation provides strong evidence that the universe is expanding in all directions, not just from a particular location. Interestingly, the expansion of the universe is accelerating. Scientists have discovered that an unseen force, often called dark energy, is driving this acceleration. While the exact nature of dark energy remains unknown, its effects are visible on the largest scales, causing galaxies to move apart more quickly as time goes on. It is important to understand that this expansion does not affect objects bound by gravity, such as stars, planets, or even galaxies themselves. Instead, it operates on the space between clusters of galaxies, gradually increasing the overall scale of the cosmos. By studying the universe's expansion, scientists can trace its history, predict its future, and better understand the forces shaping it. This ongoing growth reminds us that the universe is dynamic and ever-changing. Observing its expansion offers a calm and fascinating perspective, showing that the cosmos is far larger, more complex, and more mysterious than our everyday experience might suggest.
The question of whether the universe is infinite is one of the most intriguing in modern astronomy. On the surface, it seems simple. Is there an edge to space, or does it continue forever? The answer, however, is more complex and remains a topic of careful scientific study. Current observations suggest that the universe is extremely large, possibly infinite, but we cannot confirm this with certainty. The observable universe, which is the portion we can see from Earth, extends about 46 billion light-years in every direction. Beyond this, light has not yet had enough time to reach us, so we cannot directly observe what lies further away. This means the universe could extend far beyond what we can measure, potentially without end. Scientists also consider the universe's overall shape when discussing infinity. If the universe is flat on a large scale, as current data indicates, it could stretch endlessly. Alternatively, if space is curved in certain ways, the universe might eventually loop back on itself, creating a finite yet unbounded space. In either scenario, the universe is far larger than human intuition can grasp. It is important to note that infinite does not mean chaotic or unorganized. Even if the universe has no bounds, it still follows consistent physical laws, and matter is arranged in patterns such as galaxies, clusters, and the cosmic web. Considering the possibility of an infinite universe encourages a quiet sense of wonder. It reminds us that while we can explore and understand much, there will always be mysteries beyond reach. The question itself, whether the universe is infinite, invites reflection, curiosity, and appreciation for the vast, beautiful cosmos in which we live.
The universe is far larger than our minds can fully comprehend. From our daily experience, we understand distances in miles or kilometers, and time in seconds, hours, or years. Even the largest objects on Earth, like mountains or oceans, are measurable and familiar. In contrast, the scale of the universe stretches far beyond these everyday concepts, making it difficult for human intuition to grasp its true magnitude. For example, the Milky Way galaxy contains hundreds of billions of stars and spans about 100,000 light-years across. Even this immense structure is just a small part of the observable universe, which stretches roughly 46 billion light-years in every direction. Beyond that, there may be regions we can never see, making the cosmos potentially limitless. Such scales are far removed from human perception, where a single light-year is almost impossible to imagine. The vastness of the universe is also reflected in time. Light from distant galaxies takes billions of years to reach us, meaning we are seeing those galaxies as they existed long before Earth even formed. The universe is not only enormous in space, but also in time, creating layers of history that are beyond intuitive understanding. Despite this, the universe remains organized and consistent. Galaxies form predictable patterns, matter interacts according to physical laws, and cosmic structures like the cosmic web show remarkable order on the largest scales. Recognizing how much lies beyond our perception encourages a calm sense of awe. It reminds us that while human intuition is limited, science allows us to explore, measure, and appreciate a cosmos far greater than we could ever imagine, quietly expanding our understanding at every turn.
Even with modern telescopes and advanced technology, much about the universe remains a mystery. Scientists have mapped the observable universe, estimated the number of galaxies, and measured the distances to faraway stars. Yet the true size of the universe, beyond what we can observe, is still unknown. This uncertainty makes the cosmos both fascinating and humbling. The observable universe is limited by the speed of light and the age of the cosmos. Light from regions beyond approximately 46 billion light-years has not had time to reach us, so we cannot see them. These unseen regions may contain countless galaxies, stars, and cosmic structures that are completely invisible from Earth. Because of this, the universe could be far larger than anything we can currently detect. Another unknown is the overall shape of the universe. If space is flat, it might extend infinitely in all directions. If it is curved, it could loop back on itself, creating a finite yet unbounded space. Both possibilities are difficult to visualize, and scientists continue to explore which model best matches observations. Dark matter and dark energy add further mystery. These invisible components influence the expansion and structure of the universe, but cannot be observed directly. Their effects shape the cosmos on the largest scales, meaning there are fundamental aspects of the universe's size and growth that remain hidden. Understanding these limits highlights the exciting frontier of cosmology. While we know a great deal about the universe, we must also accept that some parts may remain forever beyond human reach.
This open-ended question encourages curiosity and careful exploration, reminding us that the universe is not only vast, but still largely unexplored,